Hello, everyone. Good morning, good afternoon, and good evening. Dear author and invited guests, welcome to Technical Session 6A. Myself, Richa, and this session will be moderated by me. On the behalf of the Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you the ninth World Conference on Smart Trends and System Security and Sustainability, WS4 2025, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 19th August, while the virtual sessions are being conducted via Zoom on the 20th and 20th of August 2025. In this session, we have a six presentation. Each presentation will be given 12 minutes for presentation and 3 minutes for question answer. After 10 minutes, I will raise a gentle reminder. There is another request. Kindly write it to me in a chat box. Just before we get started, I would Dr. Mohammed A. Tahir. Dr. Mohammed is a professor at Thomson River University, Canada. His teaching interests include optimization, computational, linear, integral, non-linear, discrete, and multi-objective operational research and a data mining. His research focused computational intelligence and evolutionary computational with application in a data analysis, big data and optimization, engineering program problems, optimal controls, wireless sensor networks, and operational research. Welcome to you, sir.
Thank you.
And we have another session today. Dr. Prashant is working as a professor and a head of the Department of Information and Technology of MIT School of Engineering in MIT ADT University, India. He has a more than 17 years of teaching and research experience. His publication include more than 25 papers in the international conference and journal. His research interests include algorithm privacy and Turing machine. Welcome to you, sir.
Thank you.
Now we start with papers. We can call our first presenter to present is a paper on integration of BIM, IoT, and AI for predictive construction management. A paper presenter is Angelio. Any present? Any presenter of this paper? Any co-author? Okay, moving ahead, we can call our next presenter is Amol Kamble to present his paper on intelligent detection on pomegranate disease using CNN and live image processing.
Hello, ma'am. My name is Hemant Nandane. I'll be presenting. Ma'am, can I share my PPT?
Sure, please.
Is it visible?
Yes, it's visible.
Okay, so good afternoon, everyone, and thank you for this opportunity. So we are presenting our research title Integrated Detection of Pomegranate Disease using CNN and live image processing. So my name is Hemant Nandane, and I'm presenting on my on behalf of my co-author, namely Rohan More, Mahesh Jadhav, Tanmay Madi, and we had worked under Professor Deepak Mane and Amol Kamble sir. So introduction. As you know that a pomegranate is a high value fruit crop cultivated extensively in tropical and subtropical region. Its demand is rising due to nutritional and medicinal benefit, making it profitable crop for farmer. However, diseases like Alternaria, anthracnose, bacterial light, Cerospora, and oily spot severely affect both yield and quality. Traditional detection methods are manual, time-consuming, and often inaccurate, especially across large farms. These methods also rely heavily on the expert knowledge, which is scarce in rural areas. With advanced AI, in particular deep learning, we now have powerful tools for automated disease detection using image classification. Our goal was to develop a system that is both accurate and deployable in real time, even in resource-limited farm environment. This work not only addresses crop quality but also contribute to food security and sustainable farming practices. Motivation. Our motivation is rooted in real-world agricultural challenges. Late detection leads to disease spread and significant crop loss. Manual inspection is slow and error-prone. Current AI solutions are often heavy, needing expensive hardware unavailable to small farmers. Environmental detection, environmental factors like lighting and occlusion reduce accuracy in uncontrolled setting. We aim to design a lightweight, robust, and field-ready solution using CNN and real-time image processing. Ultimately, this helps farmer taking timely action, reduce financial loss, and ensure better fruit quality for market. And we can see that not much work is done on pomegranate disease detection, and the work which is done had very low accuracy in the recent time. These are some of the papers we referred. Now, the problem in the current system. Existing approaches faces several issues. Like first, large model size. AlexNet variant can exceed up to 380 MB, unsuitable for mobile devices. Manual pre-processing, data splitting and lessons segmentation slow down workforces. Poor field generalization. Model degrade under real-world condition. Our system based on MobileNet V2 overcome these by offering a 75% smaller model size by quantization. End-to-end automation from raw images to diagnosis. Real point dropout architecture that curb misclassification notably and commonly Alternaria and anthracnose confused. So dataset. So we use a pomegranate fruit disease dataset from Kaggle. It has 5,100 RGB images organized into folders by class. 6 classes like healthy, uh, Alternaria, anthracnose, bacterial light, Cerospora, oil spot. Balanced class representation for reliable training. Rather than manually splitting data, we impose a TensorFlow's image data generator with the uh, native validation split and applied real-time augmentation like rotation zoom, shear flips, and brightness adjustment. This approach mimics field variability while ensuring model robustness. It also highlights the importance of dataset quality. Without diverse balanced data, even the best model underperform. So this is our proposed methodology. Our architecture leverage a MobileNet V2 for lightweight, efficient feature extraction. Input like we put input a image size 224 cross 224 and feature extractor are MobileNet V2 pre-10 on ImageNet. Frozen base to preserve LearnNet feature. Custom classification head. Global average pooling dual dropout layer, denser layer with 128 ReLU, softmax output for 5 classes. This compact design uses 1,65,125 trainable parameter, maintaining high accuracy with staying mobile friendly. An additional advantage is that the model is scalable and can be retrained for both fruits crops with minimal changes. This is our implementation. So our implementation comprises of front end, we use React.js web webinar, and in back end we use Flask API for image upload and interference. And model is like TensorFlow Keras with ModelNet V2 base. Inference in efficient OpenCV downsize farmer, normalize them and feed them to the model. We process every fifth frame to sustain real-time performance, achieving 21 to 25 FPS on the mid-range GPUs. The system support live camera detection, pre-recorded video analysis, batch size image classification with optional MP4 video out. The integration shows the practicality of our system, bridging research and real-world development. This is our model accuracy and result and evaluation phase. Our model delivered 92.3 overall accuracy, outperforming previous method. So we can see that like decision tree gave 81% and SVM 82%, KNN 84%, random forest 85%, efficient net B0 87%, and the proposed model that we use, mobile net V2, gave 92.3% of accuracy. And F1 score is a healthy 97%, anthracene and Cirrus 95%, and bacterial bright 93%. Inference time average is like 47 millisecond per image, supporting real-time applications. Learning curve shows tight alignment between training and validation, indicating minimal overfitting. Test Field test confirms stability under varied lighting and partial conclusion, proving real-world robustness. Now this is our front end, how our model works. Conclusion. This was our UI page for the project. Conclusion. To conclude, we build a lightweight, accurate CNN system for pomegranate disease detection. MobileNet V2 with dual dropout layer and global pooling enables generalization without overfitting. Extensive data augmentation ensure resilience to light and orientation and changes. The system is deployable on edge devices, empowering farmer with early accurate disease diagnosis. In future work, we include expanding the dataset to more conclusion and light variation and exploring further mobile optimization. Our research bridge the gap between deep learning research and practical farming tool, moving closer to the previous agricultures. Also, in future work, we are thinking to do this model on a tiny ML thing. So we often see that the models are a little bit heavy. So they're not really as models are heavy, and the devices that farmer uses, they don't have like very expensive, or we can say very devices that can uh, that can bear the heavy models. So we are trying to make our tiny ML model of pomegranate so it can be used by mobile devices which are lightweight, which are often used by farmers who have like less RAM and all that things. So I thank you for your attention, and we are welcome for questions if you have any.
I have a question here. Did you compare this CNN with other approach to see why your approach is better or outperform other approach existing in literatures? Or you have not really compared CNN with others, with other approach?
Yes, sir, we did compare with other approaches. Like I told in PPT also, we read that the decision tree gave like 81% accuracy, ANN gave 80% accuracy, SVM gave 82% accuracy, KNN gave 84% accuracy, random forest gave 85% accuracy, CNN gave 87% accuracy, and the proposed system that we use, that MobileNet V2, which is lightweight CNN plus transfer learning, gave 92.3 accuracy. So we first, when we started doing this project, then we use different technologies, and the one which gave best accuracy we used in this. But every technology has some drawback, like some were too heavy, were giving good accuracy, but we needed one that has like good accuracy also, and which is lightweight also. So that is like MobileNet V2, which has like 92.3% accuracy, better than the most.
Thank you.
Yes, sir.
So thank you for your presentation. My question is how your proposed model is lightweight.
Yes, sir. Thank you for the question.
So can you answer that?
Yes, sir.
Yeah, go ahead.
So, sir, as we know that we have used MobileNet V2 architecture. So that is comparatively very lightweight than the other models. We have used true dropout layer. which reduces overfitting without increasing parameter. And our model is our model drastically reduces computational complexity. Uh,
So what's the complexity of your proposed model?
Sir, like
Okay, no worries. Thank you.
sir, like our inference time is 47 millisecond per image,
In terms
which
of
is
like any asymptotic notations?
sir, I am not able to like
That's fine.
explain.
That's okay. Thank you for your questions. Sorry, answers.
Thank you so much, presenter, for your presentation. And moving ahead to our next presentation, a presenter name is Abdullah Alamari to present his paper on IoT instruction detection framework using stack-based and hyperparameter turned random forest. Any co-author of this paper? Okay, moving ahead to our next presentation. The paper presenter is Prince Kelvin to present his paper on leveraging big data analytics for enhancing security and criminal investigation in Ghana.
Yeah, hi, I'm here. Thank you very much for the opportunity. Yeah. You have my screen. You can see my screen.
Yes, your screen is visible.
Okay, thank you very much, yeah. And thank you for the opportunity. So my paper has been titled Leveraging Big Data Analytics um, for enhancing security and criminal investigations in Ghana. My name is Gibson and I'm presenting on behalf of Mr. Prince Kelvin also. Yeah. Okay, so this is the presentation outline of our presentation. So in today's digital era, Ghana generates a lot of numerous data daily from mobile apps and then social media and CCTV. While this data could transform security, it also fuels crimes like cyber fraud, organized organized scams and cyber terrorism. So traditional investigative methods cannot keep up with the volume, the three V's, which is the volume, velocity and variety constraints. And then, so the core challenge of this is that interpreting big data with the current system that we have here in Ghana, or the current approach that they use is not viable, and then so to have our research proposes a method. Our research proposes a method that can actually process this data really well and then help fight cyber crimes. So so the purpose of this research is to show how advanced analytics such as linked list, link analysis, intelligent agents, and then test mining can really enhance criminal investigations in Ghana. So the contributions, so a localized this research proposes a localized and then four-stage big data analytics framework to enhance Ghana's this is actually tailored to Ghana's infrastructure and then the trade landscape in Ghana. So the mapping the relational and then the positional data sources from for criminal intelligence, and then the application scenarios include we have the application scenarios, challenges, and then future agendas for sustainable adoption in Ghana. So moving on to the literature or the foundation of big data. Big data in security goes beyond large data. It exceeds conventional tools. To the conventional tools, we cannot exceed the volume, velocity, and variety. This the big data exceeds the conventional tools to um, due to its volume, velocity, and variety, and demanding new platform and methods. So the criminal analytics, which is uncovering relationships, rules, and then patterns across multiple data and uh, data to disrupt crimes. So Ghana in this is relevant in Ghana because it data increasing data from the mobile. We have in Ghana you have increasing data from mobile networks and then social platform, financial systems, and then surveillance feeds and other um, data sources. So this is the proposed four-stage framework to collect data, analyze, and then process and output the intelligence, which is the intelligence output. So the first one has to do with data collection. So collecting data from CCTV, mobile records, social media, the banking logs, and our mobile money and public reports, and then the processing, that's cleaning the data and then filtering, normalization and standardization. And then we have the big data analytics, which is we use the linked list analysis and then pattern detections, and then predictive modeling, and then row interference. So the output, the intelligent outputs, and then the application, we use the visual crime networks, criminal networks, and then alert systems, and then investigating the support and case profiling. So on the stage one, which is the data collection, I think I explained up there. The data collection, Ghana here we have mobile money, and then the national ID registration. So the relational has to do with mobile money logs, national ID registration, financial transactions, CCTV, and then the police reports, and then the positioner, which is the social media. We can have Facebook, TikTok, and then X, and which is the your page post, LinkedIn, and blog post. So the goal is to pull both static and streaming data from siloed systems into a harmonized lake for data downstream for analysis. So that's the goal of using data. Sorry. So the stage two, which has to do with the data processing, which is duplications and then noise removal, reformatting across inconsistent records, and then we have the normalization, the max PII to align with the Ghanaian Data Protection Act, which is the Act 2012 during the investigative analysis, and then integration and then standardization. We have the entity resolution, and then common schemas for cross-source joins, and then we have the tooling notes. So the stage three has to do with the analysis, the link analysis, which is the NS. We have the map actors and the rules, and centralities. which expose the hierarchies and then financial trails. We have the intelligence agents for autonomous monitoring or alerting across social and social or financial or telecom streams to surface anomalies behavior. And then we have the text mining or natural language processing from Hello, can you hear me?
Yes.
Sorry, I think I lost my network went off. Sorry about that. Yeah, please, am I audible now? Hello, can you hear me? Am I audible?
Yes, you are audible.
Okay, thank you very much. Yeah. So we have the predictive policing as we prioritize the hotspots in Ghana, the hotspots towns or the cities in Ghana, which is we have Kaswa and then Ashama and Tamale in Ghana here, and then we using historical patterns and then near real time fees, and then the fraud and financial crimes detection, which is real time flags, and then on suspicious mobile money flows, and then AML, the signal detection, and then we have the counterterrorism and public safety for signals from social media, and then local analytics for early warning and intervention. But the strategic ops support, so that one has to be intelligent for operation like Calm Life and then Vanguard, which is the inter-agency tasking and confliction. Deconfliction. So the method that we use the crispy DM fits. So, this methodology is for Ghana. It was related to Ghana, and then so we have the iterative cycle from pattern framing, and then data understanding. So understanding the data and then prep modeling. So these are the stages. So the stages we have the iterative cycle from problem framing, data understanding, then modeling, evaluation, deployment, and then adapt to local constraints. So data governance, access to agreements, and then quality audits, privacy and edit reviews, and then feedback loops to validate model outputs and against crime statistics, and then community responses. So the platform choice, we considered a partnership to scalable ML, and then clustering, classification, pattern recognition. So the current application and the challenges and risk in Ghana here. Currently, we have the airports and then the borders. We have facial recognition, and then the urban vehicle tracking, then mobile triangulation in kidnapping, and then we also have the open mapping concepts here in Ghana. But the key challenges here is that they have data silos, and then weak interagency sharing. So we have data silos which they are not together in the mainstream, which makes um, sharing becomes really a problem. And then we have the infrastructure gaps, and then legal clarity on cross sector sharing and rural connectivity. And then we also have the private and then public trust.
Sorry to interrupt, dear presenter. You have a last 2 minutes. Please conclude your presentation.
Okay, thank you very much. Yeah. So future research, for Ghana specific data standard and integration frameworks, which localize model for factoring seasonal trends, and then migration and conflict dynamics. So the Bangli collaboration, and then mobile money fraud. So what it takes is that the political will, so you need the political will, and then interagency cooperation, and then sustainable investment from, and then public education on these kind of crimes, and then ethical use of data. So the bottom line, a practical, and then the first stage, we propose the first stage big data pipeline for the CRISP idiom that can shift Ghana from reactive to intelligent security, and then improving prevention, investigation, and safety outcomes. Yeah, thank you very much. Hello, can you hear me?
Dear presenter, thank you so much for your presentation. Sir, any question regarding the presentation?
No questions from my side.
No
Thank you
question.
so much.
Thank you.
Thank you so much, dear presenter. And we are moving ahead to our next presenter. It's Anmol Kamble to present his paper on ordinal assemble deep learning for knee osteoaesthetics detection using X-ray imaging.
Am I audible, ma'am?
Yes.
Ma'am, students are having some problem. They will join within a couple of minutes. So please wait.
Dear presenter, we can do one thing. We can call our next presenter. After that presentation, you may proceed with the presentation.
Yes, thank you, ma'am.
So now we can call our next presenter. It's Sahid Soliman to present his paper on smart glasses for real-time navigation and obstacle avoidance for visually impaired users.
Hello, hello, can you hear me? Hello, can you hear me?
Yes, we can hear you.
Okay. Can you see my screen?
Yes.
Okay. Hello, everyone. My name is Shahid Suleiman. I will be presenting our project, which is smart glasses for real-time navigation and obstacle avoidance for visually impaired users. And this project was done with my colleagues, Wiam Shahata, Ragad Al-Asmi, and Shayma Nasser under the supervision of Dr. La Ismail. These glasses, they combine object recognition, obstacle detection, multimodal feedback, and emergency alert system into one wearable solution. Here is the flow of today's talk. I will start with the problem and the motivation, and then explain our contributions. I will briefly cover our related work, present system design and implementation, as well as play a short demo video and share our testing results, and end with the conclusion and the future work. So starting with the problem and the motivation. Globally, there is 2.2 billion people that live with vision impairment. Tools like canes or guide dogs, they are useful, but they don't provide real-time detection or object recognition. So in practice, this means that the users only find obstacles when they physically touch them. They cannot easily locate the objects such as doors or chairs, and this increases the risk as well as it reduces their independence. So our motivation was mainly to design something that is affordable, lightweight, intuitive, that improves the safety and the mobility, as well as the confidence for the visually impaired users in their daily life. So for our first contribution is real-time obstacle detection. Using ultrasonic sensors that are placed on the front, the left, and the right, the glasses can detect objects between 30 and 250 centimeters, and they can alert the users before they collide in various environments. Next up, we have the emergency alert system. So if the user falls or presses an emergency button, their live location is immediately shared with a caregiver on WhatsApp. Third, the glasses provide object recognition and navigation. So if the user asks for a particular object, say for example a chair, The YOLO version 8, which is running on the AI camera, it detects it in real time and guides the user step by step until they reach it. This makes sure that the system is more practical than just obstacle avoidance. Fourth, we're using both audio and haptic feedback. Audio gives spoken alerts, while the vibration motors, they provide tactical cues. This dual system, it ensures reliable alerts, even in noisy environments, for example, streets. Lastly, our system is hands-free. Users can interact with simple voice commands, and we included also dedicated buttons for quick emergency alerts and starting the object search. Moving on with the literature review. So previous systems, they often included three common features, which is object recognition, ultrasonic obstacle detection, and audio feedback. While these features inspired our design, we still, this search, it revealed areas where improvement was needed. So our system, it differs in three important ways. We run the YOLO version 8 directly on the system. So the system is instant, it's reliable, and it can even work offline. We also provide dynamic guidance and orientation. So instead of static warnings, we are reorienting the user and dynamically guiding him through their environment. We also use dual feedback, which is audio and vibration, making the alerts even more reliable in real-world conditions. Now I'm gonna move on with the system design. So this is our high-level architecture. It shows the system architecture. Basically, the Raspberry Pi 5 is the main controller. It collects the input from the AI camera, the ultrasonic sensors, and the IMU. It processes sensors data for object recognition, obstacle detection, and orientation. So based on this, the Pi sends out outputs through audio prompts, vibration motors. It also handles voice commands and button inputs. So in short, the Raspberry Pi acts as the central unit that connects all the inputs and the outputs in real time. And this is our hardware design. As I said before, the Raspberry Pi is the main controller, and we're also using an AI camera for the deployment of the YOLO version 8, ultrasonic sensors for obstacle detection, and IMU for orientation tracking, and the mini vibration motors, as well as the push buttons for search and emergency activations. So all the components are wired through the Raspberry Pi GPIO pins to create a compact wearable device. Here, I'm going to go through the system logic or the software logic behind the design. So basically, the system runs continuously, and it continuously looks for a button press. For example, if the emergency button is pressed or a fall is detected, an alert with live location is sent to the caregiver. Or for example, if the search button is pressed, the object recognition module is activated and starts guiding the user around his environment. Meanwhile, obstacle detection always runs in the background and provides immediate audio or vibration feedback. This is a picture of our prototype. As you can see, the camera is mounted here and the vibration motors are on the sides, and the buttons are also mounted on the glasses. For each side, there is a button. And this is powered through a USB-C power bank. And the software is written in Python, and we're using Twilio and APIs for emergency alerts. So overall, it's lightweight, wearable, we're running everything in real time. Now I'm going to show you a demo video for our project. I'm not sure if the audio is going to be shared.
Turn left. Turn left. Turn right. What are you looking for? Please start rotating slowly. The object has not been found in your surroundings. you looking for? Please start rotating slowly. Stop rotating. Move right. Move left. Move forward. You are off course. Please rotate right to reorient. Course corrected. Continue moving forward. Is this the object you were looking for? Please say yes or no. You reached.
Okay, moving on to our testing and evaluation. So we tested the system in various environments and we found out that the object recognition responded under 0.6 seconds and consistently detected common objects. Obstacle detection also worked reliably between 30 and 250 centimeters with alert triggered in about 1 second. Emergency alerts were also sent in under 3 seconds with accurate live GPS location. So these results can confirm that our system is reliable, fast, effective, and under real-world conditions. Lastly, I'm going to go into the conclusions and the future work. We developed and tested the smart glasses that combine obstacle detection, object recognition, dual feedback, and emergency alerts. So under these testing that we have done, it proved reliable, responsive, and practical for daily use. For future improvements, we are planning to add obstacle classification so the system can automatically categorize the obstacles in the environment for even more spatial awareness, as well as enable indoor navigation because, of course, the GPS does not work indoors. So planning to include Bluetooth beacons, as well as add multilingual voice feedback and integrate infrared or night vision sensors for low light conditions. That's about it. Thank you. And if there's any questions. Do you guys have any questions for me?
No question. Thank you.
Thank you.
Thank you so much, presenter, for your presentation. Now moving ahead to call our next presenter. Amol Kamble is your co-author is present in meeting.
Yes, ma'am.
Hello.
Hello. Hello.
Hello. Yes, you're audible.
Hello?
Yes.
Yes, ma'am.
Yes, can we start the presentation?
Yeah, ma'am.
Sure, please.
Ma'am, is my screen visible? Hello, sir. So my name is Devanshu Vakhare, and I am going to present the knee osteoarthritis, which we have trained using the conditional ordinal regression neural network. So basically, when we talked about the knee arthritis, it is a progressive joint disease which affects mobility and quality of life. So means accurate grading was needed, and when we moved towards the research of this particular disease, so we found out that the machine learning model, when we use the particular model for this particular disease, so it gives an accuracy of 56%, 70%. So we thought of how we can increase the uh, accuracy for this particular disease prediction. So while going through the processes, we gone through the manual interpretation of X-ray. So there was a much more processing needed, and as we know that in manual, we have to first encounter with the doctor, then we have to take out the X-ray. After the X-rays, also there was a pretty much amount of time required for deciding whether the KOA was means at what step of there are actually 5 steps of this disease that are healthy, doubtful. Then we can say the latter three are the which means you are having the KOA. So after this, we proposed an ordinal and deep learning model.
Dear
So,
author, your presentation slide is not moving.
ma'am, now
Your presentation slides is not moving. You are still on motivational, yeah, or objective slide.
yeah, ma'am. So these are some literature reviews. So what is the method we used for this particular model? So first we use the pre-processing, as we know that the knee X-ray can also consist of your thigh bone and your means flint bone. So what we do is we removed the low quality or corrupted images, and we also converted them only to focus towards the knee where the problem occurs. Then also we normalize the pixel values, which means for which we use the normalized by 224 by 224 pixels. Then while data augmentation, we gone through the as all the X-rays are black and white. We adjusted the brightness and the contrast, and then the elastic deformation and cropping was done. After that, there were 4 pre-trained models, namely VGG19, ResNet 34, DenseNet 121, and DenseNet 161. So how did we come on the conclusion that we are going to use these 4 models? So based on the previous researches and studies, we found out that these were the best 4 performing models. So we opted for this, and after that output was given by these 4 trained models. So it was passed through a conditional ordinal regression model. Now what is that? So it does not only see whether you are off the target, it also sees by how much distance are you off the target. So the more the distance is, like if a 0 is predicted and it is a 3 model, so it will give a more huge error, so that the cross entropy loss, which will be more rather than of a particular regression model. So within that, we use the Adam optimizer. So we kept the learning rate of 0.001, but during Adam, it particularly means Adam optimizer switches to learning rate on its own. So how it can whether it will increase the learning rate or decrease the learning rate. Then the ensemble head consists of 16 layers, hidden layer of 32 units with ReLU activation. So this ensemble was done after the 4 pre-trained module were passed and fine-tuned. So what you got the result was that this proposed ensemble deep learning model, it gave a accuracy of 71.2, which was far more than the accuracies which we have studied over the research papers. And the most correct prediction was given for the KL3 and KL4. Means KL3 and KL4 tells us if you are having the KOA or not. So means it is the worst condition of the KOA. So it was very important that we encounter the worst one particularly, as we know that healthy and doubtful might be not that important, but the worst one has to be shown from your system. So this was the conclusion. Coming towards the, we can show the results. So here we are showing the results. This was the confusion matrix that we got from our results. So mostly the non-predicted models are going in 0 and 1, because 0 and 1 are mostly similar, that is healthy and doubtful. But the latter 3 are the most means we can say that here is where the disease occurs in 2, 3, and 4. So it was very much convenient to us that the most of the correct prediction was to go to 2, 3, and 4. And these were the, like these are the papers that we concluded from which. So we can see in 2023 that the accuracies from a particular model were only up to in the 60th range, whereas our ensemble model gave us the range of 70. Hello, any questions, sir?
Yes, I have a couple of questions. Can you go to the slides once again?
Yes, sir.
Can you just go to the conclusion slide? So you tested this data set with your proposed model of having accuracy 71.2.
Yes, sir.
How the accuracy is calculated?
So sir, actually, when we received the data set, we divided it into 70, 10, and 20. So 70% of our data set was for training. The latter 10% was for validation, and the 20% was given for the testing.
So my question is, how the accuracy is calculated? Any specific
It's on the
formula,
testing
method?
model, sir. It's on that we developed a pickle model from that trained data, and on that pickle model was given the test data to perform on, from which we got the confusion matrix.
If you're using a multiple pre-trained CNNs, what's your observation?
So sir, mainly in all those DenseNet performs in a very particular way, but when we compare about VGG19 and DenseNet 121, so particular images were there which means in coming of contrast, like there are some images which will show the KNN from the means the knee, the X-ray of knee will be somewhat means it distance, like two of our joints will be placed far apart. The VGG19 catches that, but in DenseNet 121 we know that the cartilage tissue because which stops producing mucus because of which the KOI happens. So that was caught by the DenseNet 121. So there were some variations which was caught by VGG19, and some were there which was caught by the other models. So combining all those means mostly they will be predicting same, but the means the variable that will be not caught by some of them will be caught by the others. So means if one not catches, the other three or other two can catch them.
Okay. Last question, why the F1 score is called as F1, not F2, F3?
Sir, in the harmonic mean, we see that the recall and the we see that the recall and we can say the
Okay, no worries. Thank you for your all answers.
thank you.
Hello.
Thank you so much for your presentation. Now we can call our next presenter. It's Abdullah Almari. Alamari.
Excuse me, ma'am.
Yes.
Ma'am, do we need to submit any form for the certificates? I'm Amol Kamble.
No, sir. So you will get all the certificate after 2 working days, the
Okay.
end of the session.
Yes, yes. Thank you, ma'am. Thank you very much.
So we can call our next presenter. To present is a paper on IoT intrusion detection framework using select K-best and hyperparameter turnaround forest.
Good afternoon. Is my voice is clear?
Yes,
And presentation?
yeah, it's visible.
Please just make
Good
it
afternoon, esteemed colleagues and guests. I'm honored to present my paper on efficient IoT intrusion detection framework using select key bits with hyperparameter tuned random forest. My supervisor, Prof. Hisham Nabi, Ghada Dahi from Egypt and Cairo University, Department of for Information Technology, Faculty of Computers and Artificial Intelligence.
Can you make
Our
it
agenda
full
today,
screen?
yeah, full screen.
Oh.
Okay. We will talk about introduction, problem statement, related word, research gap, and so. In October 2016,
You are on
Amirai
first
IoT.
slide, Mr. Abdullah Almari. You are on only first slide.
Just. What about this?
Now it's okay.
Okay. Is the presentation is short?
Yeah, go ahead.
Yeah. In October 2016, Amirai IoT botnet DDoS attack on DNS provider Diane disrupt a major virus service and expose a critical IoT vulnerability. With rapid IoT growth in sensor, 5G and cloud expanding attack surfaces, and diverse protocol hindering unified security, there is a pressing need to enhance protection. This research used the TON IoT dataset with select key-based and TON random forest to improve IDS accuracy, efficiency, and threat mitigation with a minimal human input. Problem statement. Against this backdrop, IoT expansion heightens risk like DDoS attack and data breach, while diverse device and protocol hinders uniform security. Traditional IDS relying on known signature fail against new attack, demanding adaptive, accurate solutions for resource-limited IoT device. Research gap. To address this gap, this framework improve IoT threat detection using the TON IoT dataset with optimized machine learning, reducing overfitting and computational load. It also classifies IoT vulnerabilities, addresses flaws in traditional security, and evaluate feature selection impact, and validate IoT environment to establish a best practice. Related work in parallel. There are several studies in this field, including number 4, Narcomedia and et al., which use hyperparameter random forest to improve intrusion detection accuracy, and Jamshidi, which applies a feature selection with a machine learning to enhance the performance and efficiency, both closely related to this research. Research question. Accordingly, how can we optimize a machine learning algorithm combined with effective feature selection be leveraged to enhance accuracy, efficiency, and adaptability of IoT intrusion detection system using dataset like TON IoT? Research objective. To answer this question, this research seeks to optimize feature selection and machine learning models using the TON IoT dataset to enhance IoT threat detection, accuracy, reduce overfitting and load, and enable near real-time detection. Dataset and methodology. Methodologically, the TON IoT dataset contains 461,043 samples and 45 features, covering normal and attack events for AI-based evaluation. The proposed end-to-end IoT threat detection framework includes 5 stages. Pre-processing stage, we get data selection and cleaning and normalization. In analysis and visualization, we perform a statistical analysis, class distribution, and correlation heat map to understand the visualized variable correlation. In feature selection, we use select keybase with matchable information for feature relevance ranking. In classification stage, we use a random forest with a grade search hyperparameter tuning for optimize the model performance. In evaluation accuracy-based performance measurement with a feedback loop for model retraining. Experimental result. Class distribution adjustment. Empirically, the TON IoT dataset initially showed a significant imbalance with the normal class at 290,000 symbol, approximately equal to 65%, and attack symbols at 170,000, less than 35%, leading to model bias and weaker free detection. So, downsampling was applied to equalize the classes, resulting in 160,000 symbols, each for normal and attack. This balancing ensures fair training, improve detection accuracy, and enhance model generalization. Also, in experimental result, we compared our proposed framework with 10 classifiers. In addition to the proposed model, we evaluate several classifiers on the data set. The comparison shows that the proposed model achieved the highest accuracy, reaching 100% before balancing, and 98.79% after balancing, after downsampling. This surpasses other classifiers such as gradient boosting, k-neighbors, and decision tree. Also, model accuracy comparison with prior research. We compared proposed model with the prior work. The comparison show that the proposed framework achieved the highest accuracy, approximately equal to 99% after downsampling, outperforming prior research modeling. This demonstrates its superior effectiveness in IoT3 detection over a virus advanced machine learning and hybrid approach. Conclusion and future work. In summary, the proposed framework achieved accuracy approximately 99% after balancing using acceleration analysis, select keybase, and tuned random forest, outperforming strong baseline. In future work, will develop lightweight, energy efficient models validate across diverse IoT environment. This, my reference, and thank you for your attention. Question, please say question slowly.
Okay. Thank you so much for the presentation here. I have a question here for the feature selection that you mentioned. What kind of approach in the feature selection you are using? That's number one. Number two, are you using feature extraction or just feature selections?
Okay, first, we perform a correlation matrix to understand the data. The framework select keybase with the matchable information as the scoring strategy. Matchable information measure how much knowing one variable reduce uncertainty about another. In selection versus extraction, that's your question, it use feature selection only, picking the most relevant feature, not feature extraction, will transform feature into a new ones. In short, I think select keybase plus matchable information that give us the variables that have a high and correlation with us, feature selection, not extraction. Thank you.
Which approach you are using from feature selection? Are you use BCA or you are using rubber, or what kind of approach you are using from feature selection?
CV crossfold with 5 and hyperparameter.
Okay. Thank you.
Thank you. Any question?
No question.
Thank you all.
Thank you so much, dear presenter, for your presentation. And we have completed all the presentation and now we conclude this session. I sincerely thank our author and their excellent presentation and contribution in this session. We all participants and being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for support during the 9th version and the previous 8th version of the conference. We will be happy to have you in the next 10th version in 2026. All the presenter would be getting digital certificates within 2 working days through email. The publication will be live 7 to 8 months. Kindly cooperate with the team of WS4. All the presenter would, and further, I would like to thank our chair of this session, Professor Mohammed E. Tahai. Well, thank you so much, sir, for your valuable presence.
Thank you.
And Professor Prashant Dhotre.
Thank you. Thank you,
Thank you
team.
so much, sir, for your valuable presence.
Yeah, pleasure is all mine. Thank you.
Now, I would like to request to everyone to turn on the camera to take a quick snapshot for this virtual conference. Thank you so much, everyone. Thank you so much, sir.